Welcome to 9.5, the sine and cosine ratios. So let's just talk quickly about SOHCAHTOA. All right, so we did tangent yesterday, and tangent was the opposite leg over the adjacent leg. Well, sine is the opposite leg over the hypotenuse, and cosine is the adjacent leg over the hypotenuse. So we need the hypotenuse today, and that goes in our denominator. All right, and it does depend on which corner of the triangle you're working on. And one last thing, the angle of depression. Depression means you're going down. So yesterday we talked about elevation, which meant you're going up. Angle of depression is from a horizontal line going down, and that gives us a degree of that angle. Okay, we want the sine of D, the sine of E, the cosine of D, and the cosine of E. So we're just going to put this on both of these. Okay, so the sine of D is the opposite leg over hypotenuse. Again, circle your hypotenuse. These are the things you're going to be using. These go in your denominators. So the sine in SOHCAHTOA is opposite leg over hypotenuse, 15. And that reduces by 3 to 4/5. And as a decimal, 0.8. The sine of E, going from the E corner, the opposite leg is 9 over the hypotenuse, 15. Reduced by 3, we get 3/5. And that is approximately 0.6. Not approximately, it actually is equal. And now the cosine of D. Cosine is the adjacent leg. So at D, the adjacent leg, the attached leg, is 9 over the hypotenuse, 15, which we already have our answer up above. And the cosine of E is going to be the adjacent leg over the hypotenuse. And so those are complementary or co-functions with the sine. So sine and cosine are co-functions in the opposite corners. Okay? Now we do sine of D in number 2, the opposite leg over the hypotenuse. And then we use our calculator. Of 35 divided by 37, and we get 0.9459. Okay, and now the sine of E is the the opposite leg, 12 over the hypotenuse. And so we take 12 divided by 37, and we get approximately 0.3243. Now cosine of D, let's use a different color here. Cosine of D is the adjacent leg over the hypotenuse, so 12 over 37, which we already have the answer. And the cosine of E is the adjacent leg, 35 over 37. And again, we already have our answer there. All right, let's move on. Do the same thing here. So sine of D, sine of E, cosine of D, cosine of E. And we'll just do both of these at the same time. So the sine of D is the opposite leg, 28. Let's circle our hypotenuses here, over 53. So we take 28 divided by 53, and that gives us approximately 0.5283. And then sine of E is the opposite leg, 45, over the hypotenuse, 53. So 45 divided by 53, and that's 0.8491. Cosine of D is going to be the adjacent leg, 45, over 53. Already have the answer. And the cosine of E, the adjacent leg, 28, over 53. And that is 0.5283. Now the sine of D in the number 4 is the opposite leg, 36 over 45. So those are both divisible by 9. We get 4/5, which is 0.8. And the cofunction of that is going to be cosine of e. Those go back to back. All right. And then the sine of e is the opposite leg, 27 over 45. Again, those are divisible by 9. You get 3/5, which is 0.6, which is going to be the cosine of d. So these are cofunctions, and these are cofunctions. Cofunctions mean they give you the exact same answer. All right, same thing here. Sine of d, sine of e, cosine of d, cosine of e. So the sine of d, opposite leg, 13 square root of 3, all over the hypotenuse, 26. 13 reduces 26 evenly, so square root of 3 over 2. So you take the square root of 3, divide it by 2, and you get approximately 0.8660. And again, that's a cofunction with cosine of e. You still need to make sure you understand what the answers are. So that's square root of 3 over 2. They're the exact same things, 0.8660. Now the sine of e. The sine of e is the opposite leg, 13 over 26, which is 1/2, or 0.5. Cosine of d should be the exact same thing. Cosine of d is 13 over 26, which is 1/2, or 0.5. All right, now, sine of d on number 6, the opposite leg is 8, hypotenuse is 17. So 8 divided by 17 is 0.4706, which that's going to be the same thing as the cosine of e. The opposite corner. Sine and cosine are the same in opposite corners. Okay, now sine of e, the opposite leg is 15 over 17. So 15 divided by 17 is 0.8824. And the cofunction is going to be the exact same thing. All right, write the expression in terms of cosine. So cofunction means they're complementary to each other. All right, so the sine of 37 degrees in one corner is equal to the cosine of its complement. 90 minus 37 is 53. So these two are the exact same values on your calculator if you put them in. So the point is, whatever your degrees are, they're complementary for the cofunctions to be equal. So all you have to do is take the complement. So that's number 7. Number 8, the sine of 81 is equal to the cosine of 9 degrees. All right, sine of 29 is the cosine of 61 degrees. And the sine of 64 is equal to the cosine of 26 degrees. Write the expression in terms of sine. Same thing. 90 minus 59 is 31. Cosine of 42 is equal to the sine of 38 degrees. Cosine of 73 is equal to the sine of 17 degrees. And the cosine of 18 is going to be equal to the sine of 72 degrees. All right, find the value of each variable using sine and cosine. Okay, so this is what we've been given, so we're going to start at that corner. All right, so to get y, if we want to get y, that is the adjacent leg, and we have the hypotenuse. So we would say what uses the adjacent and the hypotenuse? That would be cosine. So you take the cosine of the angle, and that equals the adjacent leg, y, over the hypotenuse. And so now we multiply by 18. Take your calculator. 18 times cosine of 32, and y is equal to 15 point, let's see, are we rounding it? I don't know what the big idea is rounding it, but we'll do 15.3. All right, now to get x is the opposite leg to 32 degrees. So the opposite and the hypotenuse would be sine. So the sine of 32 degrees is equal to the opposite leg over the hypotenuse. And again, to solve this, multiply by 18. Take your calculator and find the sine of 32, and then times that by 18, and we get x equals 9.5. Number 16, we're at this corner, and let's just go ahead and do the opposite leg over the hypotenuse. So that's the sine of 64 degrees is equal to the opposite leg over the hypotenuse. Again, to get p by itself, we multiply by 34. Take your calculator and do the sine of 64 first. And then you can multiply that long number times 34, so you don't have to write it down. And that gives you 30.6 for p. All right. And now q to 64 is the adjacent leg, so that would be the cosine of 64 is the adjacent leg, q, all over the hypotenuse 34. And again, multiply by 34. Okay, so now take the cosine of 64 first. Oops, cosine of 64 times 34, and we get 14.9 is equal to q. Now, before you stop on each of these problems, make sure the numbers seem to be appropriate numbers. That way you can guess that you did it horribly wrong or that you probably got it right. So all these numbers look proper. All right, number 17. So here we are at 71. Again, I'll just start with the opposite leg again. There's our hypotenuse. So the sine of 71 degrees is equal to the opposite leg over hypotenuse. Multiply by 5. Now find the sine of 71 first. And multiply that by 5. And we get 4.7. Again, this is approximation. Now to get w, the w is adjacent. So this would be the cosine of 71 degrees is the adjacent leg, w, over the hypotenuse. Multiply by 5. So w equals, find the cosine of 71 first. So cosine of 71 is 0.3255. And take that long number times 5, and we get 1.6 approximately. So those numbers look to be proper. W is a very short leg. And now let's go to number 18. We're starting at this corner. And we'll do the opposite leg again. The sine of 43 degrees is equal to the opposite leg over the hypotenuse, 26. So multiply by 26. See, this is very different than the tangent from yesterday because you usually had a variable in your denominator, which we still might at this point. So S is equal to sine of 43 on your calculator, and take that long number times 26. And you get 17.7 approximately. All right, there's 1. Now to get R is adjacent to 43, so that's cosine of 43 is equal to the adjacent leg over the hypotenuse again, multiplied by 26. So now take cosine of 43 on your calculator, and then multiply that by 26. And R is equal to 19.0. All right, next. Now, 19, we're at this angle, and notice that the hypotenuse is now a variable. So that's going to put that in your denominator, so we'll have to work it like we did with the tangent function. Okay, so let's again start with the opposite. When we do that, look what happens. The sine of 48 is equal to the opposite leg over the hypotenuse. We can't solve this until we know one of those two variables. So now that means we should start with cosine. So the cosine of 48 degrees is equal to the adjacent leg over the hypotenuse. Once we get the hypotenuse, we can plug it back into the first one. All right, so the problem is it's in the denominator, so to remove it, we multiply by it. All right, and then to remove the cosine of 48, we have to divide by it. So I'm going to write this out to make it look a little bit better, and then the next time I'll just do it a little bit faster. So now, you don't want to find the cosine of 48 first, but it's tricky how you do this on your calculator. Be very careful. Here's how I would suggest you do it. 10 divided by, put a parentheses in, and then however you figure out the cosine of 48, and then close the parentheses, and then hit the equal sign. And if you do that, you should get 14.9. And that looks about right for the hypotenuse, okay? That's approximation. So now we can plug it back into the sine of 48 equals b over a. A is 14 now, 0.9. So we multiply by 14.9 on both sides. And we're left with b on the right. So now we can do the sine of 48 first. And multiply that by 14.9. And we get 11.1. And those numbers look to be correct. Okay? Now number 20. If we use cosine, there's your hypotenuse. That means we're going to have two variables. So let's go ahead and do sine first. The sine of 50 is equal to the opposite leg over the hypotenuse. Again, we have to multiply by the hypotenuse to remove it. So n times the sine of 50 equals 8. And now we divide by the sine of 50. Okay, so n is equal to, and again, be careful, 8 divided by, make sure you use grouping symbols, however you figure that out. So I'm going to do the sine of 50, 8 divided by, parentheses, the sine of 50, parentheses closed, and then I'll hit the equal sign. So n is 10.4, which that is probably correct. All right, so now let's do cosine. The cosine of 50 is equal to the adjacent leg over the hypotenuse. And now the hypotenuse is 10.4. Okay, so multiply by 10.4 on both sides. And m is equal to cosine of 50 times 10.4. That gives me 6.7 for m. Now all those numbers seem right. The hypotenuse is the biggest number. All right, last one here. Describe and correct the error from finding the sine of a. So let's do sine of a. Sine of a is equal to the opposite leg over the hypotenuse. So that'd be 12 over 13. Now what did they do wrong? They did the adjacent, which would be the cosine. Okay, so that's what they did wrong. All right, and then the next page is your answers. There they all are. And notice that we have the 6.7 and 10.4 in that one problem. And all these numbers are correct, I do believe. Okay, good job.